This is the third set of notes on the Pythagorean theorem. We already should have a picture on page 53 that shows the theorem. We should already have down the two parts of the Pythagorean theorem, okay, which you can write more easily if you want to, as if a squared plus b squared equals c squared, then it's a right triangle. And if it's a right triangle, then a squared plus b squared equals c squared. We've already learned that there are four parts of a right triangle. There is the right angle itself, which will be marked like this. There are the measurements of the two legs, which are the shorter side, and there are the measurements of the hypotenuse. We also know how to use the Pythagorean theorem to find out whether it's a right triangle or not. And in the last video, we learned how to use the Pythagorean theorem to find out if it is a right triangle, how to use the lengths of the sides or the legs to find out the length of the hypotenuse. Finally, we can also do the last thing, which is, if we know it's a right triangle, use the length of the hypotenuse and the length of one of the legs to find out the missing side. Okay? That's called the case of the missing leg. Pause the video if you have to get these notes on page 55. Number 1, you're going to label all the sides. Number 2, substitute values for the variables, a, b, and c. Number 3, square the values you know and solve the equation for the missing variable. And finally, number 4, take the square root of both sides. Let's use this as an example. We already know this is a right angle, so we already know, because we built it that way, we already know that a squared plus b squared equals c squared. The length of b is 4, the length of c is 5, so we can go ahead and substitute those. We'll square them. Now it gets a little tricky. Now we want to isolate the variable a all by itself, so we're going to have to take away 16 from both sides. That's going to give us a squared equals 9. We don't want a squared, we want a. Take the square root of both sides, and we get a equals 3, which is what we know it should be. Let's write an example down in our notebook. All right, first of all, we're going to label the sides. Draw this triangle, we're going to label the sides. Okay, C, again, is always the side opposite the right angle. That is going to be C right there. Okay, and that's the important one. If you get C right, other ones don't matter as much. Let's call this one A, and let's call this one B. All right, now we're going to write the Pythagorean theorem. A squared plus b squared equals c squared. We can substitute 4 for A and 8 for C. We do the math. We subtract 16 from both sides, and we're going to get b squared equal to 48. Take the square root of both sides, and b will equal to 6.9. Now, you may also see this way. You may also see it in a multiple choice question, for example, as, okay, one of these choices, and your job is going to be to make sure you get the one that is equal to 6.9. In order to do that, you're going to have to say, okay, what's the square root of 3? Multiply it by 4. What's the square root of 3? Multiply it by 5. You'll find that this one is equal, more or less, to 6.9, and that it is equal to the square root of 48. If you want, okay, let's do one more example. Again, we're going to label the sides. This one opposite the right angle. We don't know if it's the longest yet. It looks the longest, but we don't know that. But we know it's opposite the right angle. That's going to be C. We'll call this one A, call this one B, and again, we'll do the math. If you want to put that in your notebook too, go ahead.